Ben Alpert is a member of the React core team at Facebook. Ben, welcome to Software Engineering Daily.
Thank you.
We're doing a week of shows about React on Software Engineering Daily, and one thesis I have is that React has the potential to be as influential on application development as iOS has been. From your position on the inside, on the React core team at Facebook, do you share this view?
Yeah, I mean that's an interesting question. I think that the creation of iOS and the new phone paradigm really created a whole bunch of different types of software than had previously existed. These apps are not really quite like anything that came before. I would say that React isn't exactly like that in that we're not really making new types of apps. But what React does is it makes it a lot easier to build apps. It makes them a lot easier to reason about and think about. And so what that means is that it's easier to build more complex apps that work really well and don't have bugs. And it's also easier for people who don't have a lot of experience to get up and running and start making their own apps. So I think what we'll see is over time. We'll see people who don't really have programming experience, or they only have a little bit. They've just dabbled in it, making serious apps that either are just for themselves, and they want some sort of reminders app, and they want it to behave in a very specific way, just for their own personal workflow, and they can build that. Or you'll also see people who previously wouldn't have thought of building apps, getting into the app building market, if you will.
And I'm very curious about how the team dynamics and the software development culture has evolved on the React team, because I think of Facebook as this very bleeding edge company in terms of development, and it seems like you guys do a lot of things that are maybe fringe or can't be done at other companies, perhaps because the engineering quality is not high enough at other places. How does being on the React team compare to the more general types of application development and software engineering management styles that you've seen?
So I don't think that in some sense, I don't think that it's that different. You're just still trying to build the best product for your users, and in our case, the product is a JavaScript library, and our users are other developers who are trying to build their products. But other than that, I don't think it's actually that different. I think that if you could have some startup that's only a few people build React just as well. But it's probably going to be hard for them to get funding, because how are you going to monetize it and that sort of thing. But at Facebook, we're trying to build the best developer experience that we can, so that it's really easy to build these programs, and that's easy to justify when you have hundreds of developers building these products. Yeah, I mean, I don't think the people are really different from anything else. But
does the social nature of the product that you're building, well, Facebook as a whole, does that make the development more social, or does it change the dynamic at all?
Not too much, I think. Facebook's obviously known the most for Facebook.com and the Facebook mobile apps, but there's actually a ton of different projects here that are using React and related projects. So they're not all built with a social component, but of course many of them are.
I want to get an idea for how Facebook sees optimal web development, or some picture of web development. So I'd like to talk about how best practices have come to light using React and GraphQL and Relay and Flux Architecture and all these other things, these inventions and paradigms that have come out of Facebook. Because I've seen these things individually, but I'd really like to understand how they fit together and map out a future of engineering.
Yeah, so I think that we're just trying to figure out what's the simplest way to build applications, and what that means is in most cases going higher and building abstractions on top of what people are used to using. I mean, when the language C was created, you had people saying, "Oh, I don't want to use C because I don't know what assembly it's going to compile into, and it's going to be slower than the assembly I would have written myself," and all these sorts of things. And now basically nobody writes pure assembly anymore, and everybody writes in C or usually a higher level language than that. And I think you'll see the same thing with React and Relay and these sorts of projects, is that they try to abstract away these details that you don't really need to think about when you're using them. And what that'll mean is that, yes, in a few cases you have a little bit less control, but on the whole, it'll just be less work, and your programs will work just as well as they would have, and they'll actually work better because instead of spending your time trying to figure out which line of assembly you made a typo on, you can just be actually building products.
Okay, so let's talk about some of these specific products. What is Relay?
Yeah, so Relay is a framework we've just released. We released a technical preview a couple months ago, and then the sort of first first real version, if you will, was released on Monday, just a couple of days ago. And what it is it's a way to write exactly what data your individual components need, and to make sure that they all have the data they need without having to centralize all of this logic and split it across many files. And so, one example is, if you're, like, say you're on, like, you're building Facebook, and then for you want to try a test where under each comment you say how many friends the person who commented has, or something like that. I mean, traditionally you would need to make changes to the server that's giving you that data so that it can send down that number, and then you need to make changes to, obviously, the component that actually shows that data, but oftentimes also a bunch of components in the middle you'll also need to change so that they can pass down the data. And so what Relay really does is it's a way to kind of centralize that logic. So the only thing you need to change is the one component that you're changing. And so you can just say, oh, I want to also get the friend count for this user that's the author of the post. And of course, the server needs to understand how to support that. And so that's where GraphQL comes in. GraphQL is, it stands for Graph Query Language. It's really this protocol that has been developed here for clients communicating with the server about exactly which data they want to fetch. And so this is done in a way that the server can expose 30 fields and say, like, oh, the user has a name and an address and a phone number and a number of friends and all of these things. And most of the time the client won't want all of that data, but what you can do is, when you're making the request, you can say exactly which fields you want. And the most important thing about GraphQL is that it actually lets you also traverse across relationships to other objects in what we sort of think of as the graph of objects, although you don't need to store your data in a graph database or anything like that. But that means that you can say, oh, I want to get this user's friends, and for each friend, I want to get the friend's name and relationship status. So what this does is, you actually just have this one endpoint that the server serves, and whenever the client makes a request, it goes to this single endpoint, but then the client can say exactly what data it wants to fetch, and then it will get that back from the server. And so then when you're adding a piece of data to a particular client or to a new view in that client, you won't need to make any changes to the server as long as something else has once asked for that same piece of information. You've built out that support in the server, but you don't need to make a change every time you want to add something.
If I'm building a web app just in regular React, at what point do I need to start considering fixing or fitting in Relay and GraphQL, and how much burden is there in terms of integrating with those other technologies?
Right. Yeah. So that's a good question. I mean, this is something I don't think we have a great answer to. There's no just flow chart that's like, should I use Relay for this project, or should I use it right now? I mean, it's true that when you adopt Relay, your server needs to understand GraphQL, and that actually isn't as big a change as a lot of people initially think when they hear about it. It's more like you're just adding a new API endpoint to your application, but this is a layer on top of all of the business logic that you already have and on top of the database. So you don't need to actually change anything about how your data is stored or anything like that. It just exposes it in a slightly different way. Some people think of GraphQL as sort of a REST competitor. So instead of making these REST endpoints, you just make this one GraphQL endpoint, but it's still just a thin layer on top of your application code. But you're absolutely right that it is more changes that you need to make, and you need to make this trade-off of do you want to put up the upfront work in order to be able to use Relay? And I think that for most apps, the answer is actually just going to be yes. I think that Relay gives such huge advantages in speeding up your application development. I mean, everybody I've talked to really likes it and really enjoys developing with it because it lets you move a lot faster. And for as long as React's been out, React solves this view management piece of your applications where you just say what you want it to look like, and then you don't need to think about what specific updates need to be applied to make it look like that. React takes care of that for you. But then people would say, well, React is great, but I'm still doing all of this manual management of my data. I need to figure out when to fetch it from the server. I need to store it locally, and then I need to make sure that when I ask the server to change something, then I also update my local cache of it, and all of these things that were really similar to basically the manual work you were doing when manipulating the DOM or manipulating these views manually. You're having to do with your data, and so we sort of think of Relay as the React of data fetching, in that it tries to make it so you don't have to think about a lot of these things. And so the upfront cost right now is significant, but I think we'll always be looking for ways that we can reduce this so that somebody who's just starting a new project can just start and get up and running with Relay in a few minutes or half an hour.
Is there any roadmap to a Ruby on Rails type of development experience around React? Because you see all these these different things, React and GraphQL and Relay and Flux Architecture, that kind of guides users towards something. Is there a framework coming?
I think that this is something that will happen more and more over time. I don't know if you'll ever see exactly one complete package that is just one command where you can just say like Rails new and Rails start and Rails generate scaffold. But we do design all of these projects to work together really well. And actually at Facebook, our version of Relay includes its own version of routing, so that when you click on links, it doesn't need to reload the page, and it can just open the new view corresponding to the URL for whatever route you clicked. But when we were looking at open sourcing Relay, we looked at what's out there, and of course, you have these projects like React Router, which is not a Facebook product, but it does basically the same thing. And so instead, we just sat down and said, well, why don't we just make Relay work with React Router instead? And so that's what we did, and so we have all of these separate projects, but they all work together really well, and we'll try to flesh out that story and make that clear. I think that we need to rewrite the tutorial on the website now. It's getting a little outdated, but
the loose coupling is really admirable in the sense that it's kind of like humble, and it's not like trying to boil the ocean or say you have to do things this way. It's like, here's some stuff, and you can play with it, and you can do what you want with it. And if you want to build higher level stuff on top of it, go right ahead. But it is at this very comfortable level of abstraction that seems very purposeful.
Yeah. I mean, that's definitely true. I mean, at Facebook, we don't really have, we never say like, here's the new framework, it's called React, and you have to use it for all the code that you're writing from now on. Go. Instead, we just say, hey, we built this new framework. It has, these advantages, or at least we think it has these advantages, and we're interested in finding somebody who wants to try it, and we actually have to convince people that it's good and that they should use it, and so that's one reason that we actually end up focusing a lot on the developer experience, is because that's how you get developers to use your library, is if it's a lot easier than the existing stuff that they've been using. And so we really try to build out these products so that you can adopt them incrementally without having to just sell somebody and say, oh, well, yeah, we have like all these things that work together. We have React and we have Relay and you have this router, and who knows what else goes together in that. And trying to convince them that they have to rewrite their whole app is a much, much harder proposition.
The one contrast with this that I've seen is Meteor. Have you looked at Meteor much?
I've looked at it a little bit, not in detail.
Okay. Well, yeah, I don't know. Meteor's interesting because my understanding is it does a lot of things in a sort of React way, or stuff that is in accordance with the React paradigm or the Flux Architecture paradigm, or whatever you're supposed to think about. But it does actually have more of that end-to-end, Meteor new feel.
Mm-hmm. Yeah. I mean, it's you can obviously go either way. I think the incremental adoption story is really important to all of us, and that's actually, I think that was necessary to it being adopted at Facebook, and also, if you look around at these other big companies that are adopting React, like Netflix and Airbnb, and there's a ton of them, but I don't think most of them would have ever considered React if they had to rewrite their whole application in order to start using it. I mean, that's just a total non-starter. And so
Sure.
What React allows you to do very intentionally is just convert, a very small piece of your app, and you can just use React. And then, now that Relay's out, if you want, you can use React and Relay, but still only on that small piece. And if you like it, then you can build that out into more and more of your app, and maybe eventually the entire application. But we do always want to keep these pieces really small and decoupled so that you can continue to do that sort of thing.
How have Netflix and Airbnb, or I don't know to what degree you've seen their code or what they're doing, but I'd love to hear anything you know about how they're adopting React and the other Facebook technologies, and if it contrasts or surprises you in any ways, perhaps being different than Facebook.
Yeah, I mean, it's I haven't seen any of their code. I guess I've heard the most about Netflix, so I can talk a little bit about that. I mean, they just a few weeks ago rolled out a complete redesign of their website, which is basically 100% written in React. And I guess that this is actually after they've been using React on a few other things for many months now. And one of the lead guys there, Jafar, talked at the React conference we had at Facebook back in February about what they're doing. And what they actually did is they took React and adopted it to run on TVs, because that's a huge part of what they're developing for. And so, we originally developed React for the web, and then we all supported it to iOS and Android in React Native. But what they did is they took a similar approach and figured out how to adapt Relay to their very specific UI framework for building apps for TVs. And this is super cool, and I guess they've been working on this for a while now, but that worked really well for them, and now I think they're using it across their whole website. Now, they're not using Relay. I mean, partly because we just open sourced it, but they actually have their own data fetching system, which is similar in a lot of ways. And
is it Falcor?
Falcor. And what that does is it takes a slightly different approach. In Relay, with each component, you need to define exactly which data your components want to fetch up front, and then what Relay does is it actually looks through the entire component tree and figures out what data every single component needs, and then sends that all as one request to the server. What Falcor does is it actually makes the programming model a little easier than that, and what it does is it makes it so that in your render function you can just ask for pieces of the data as if you had the entire database locally, and what it will do is it'll just give you some placeholder at first, but then since you tried to access it, it will then go to the server and try to fetch that and then bring it back to you sort of transparently. And this has some advantages and some disadvantages. Obviously, the programming model is a little nicer. It does mean some other things, like you actually have more round trips to go to the server, and it can also be a little bit harder to reason about because you're not always sure exactly which pieces of data you have fetched locally, because it could have fetched one piece and not the other piece, and you need to figure out what you should display if that's the case. Whereas with Relay, you always have the data up front. But actually, I think these trade-offs are perfect for Netflix because, in terms of the extra round trips to the server, when we talk to them, it's clear that they're not actually really concerned about high latency, low bandwidth connections because if you have a slow internet connection, then you're not going to be watching Netflix videos anyway. And so that's just not a use case that they have to optimize for. Whereas at Facebook, we try to optimize for phones with very low bandwidth and try to optimize for that use case. And so there's slightly different trade-offs there. And then also in terms of the data, sometimes being available and not being available, this is actually something that Netflix engineers are very used to because for basically all of the code they use a framework called RX, which is called reactive programming. It's actually not really related to React, despite the name similarity. And what that does is it is basically a framework for dealing with asynchronous data and transforming it and mapping it, and so that you can do something like say, oh, here are these like 100 requests I want to send to the server. I want to send them 5 at a time, and then retry if any of them drops out. And that sort of logic is really easy to express in just a few lines with Rx. And so they write almost all of their server code and I think client code using this sort of mental model. And so for them, they're just absolutely used to dealing with this sort of thing, and Falcor fits really cleanly into their model of how they think about asynchronous programming in general. So I think it's a great choice for them.
So speaking of porting to other devices like TVs, let's talk about React Native in more detail. React Native allows users to build native apps using React. And if a developer writes a React web app, I'm curious about the process of porting it to iOS and Android. What is that process like?
Yeah, I mean, that's a good question. I mean, right now, to be honest, it's not, we're not at the point yet where you can share a lot of your Vue code and the actual code that you wrote for React. And right now, the biggest advantages come from the shared programming model, in that you have to rewrite your code when you're porting to be a native app, but in some sense, all of the learning you only have to do once, and so you still have the same component model, you still have the same lifecycle methods, and everything behaves almost exactly the same as it does on the web. And so that's huge, because previously people have to spend months getting up to speed on iOS just to be productive, and then they would also need to spend months getting up to speed on Android in order to be productive. And so that's why you don't actually see people who often do both iOS and Android, is just because there's a lot to learn for both of them, and it's just more work if you want to be an expert in both of them. So what we're trying to do is make it so that you only need to really learn one paradigm. And so your code will be slightly different from the web, in that instead of divs and spans, we have a component called view and one called text, and but it's very, very similar type of code. And so that allows you to easily bring your knowledge over.
So does React Native have users, or developers, I should say, presenting their apps in a DOM format? Like, is there a virtual DOM in React Native?
Yeah, so it actually works very similarly to how it does on the web. I mean, on the web we have this virtual DOM which is just this lightweight copy of what we think the DOM should look like, and then we have the old version and the new version. We can sort of diff them and figure out what operations we need to do in order to change the actual browser DOM. And on React Native, it works actually almost exactly the same way. We use the same diffing code in the JavaScript engine that we run. And then what we do is, once we've found the differences that says, create this view, or change the text of this view to this, or change the color of this other view to that, or move this view around, we just have this list of instructions for what changes we want to make, and then we actually send those over to the native code and execute those operations on the native views. And so on iOS, we're using the real views provided by UIKit, and similarly on Android, we're using the real native views. But since those view systems are somewhat like the DOM, in that they expose sort of this imperative API where you need to create them and destroy them and manage the lifecycle, the implementation of React Native ends up being very similar to React in that sense. But then
is there any significant latency in converting the DOM model or the JavaScript model? I'm not sure exactly what the model is, but you have to convert some model into native code. So is there significant latency there?
Not really. I mean, this sort of gogoes back to how I was talking about, C versus assembly earlier. I mean,
Right.
the work of diffing the two DOMs and sending it over is always going to be slower than if you were to go and modify exactly the views that need changes, and if you just knew that up front. But in most code, it's a huge pain to try to keep track of all of that. And so if you use React, then your code will, yes, it'll be a little bit slower, but it means that you need to think about a lot less and keep track of a lot less when you're actually programming it. And if you actually do run into performance problems, which is certainly possible, and we haven't optimized it as well as we can yet, and we're always working on that. But if you run into performance problems, then we do give you a way to sort of drop down and send direct commands to the native views.
Oh, wow.
And bypass the React diffing algorithm.
Is there any interesting threading model between the native, between the conversion of the DOM type of model to the native model?
So I guess that what we're doing with threading is on React Native we run all of the JavaScript in one thread, and so that includes all of your app code and also most of the actual React JavaScript code that runs on one thread. And then we have a second thread for doing the layout computation, which we use we do based on the CSS Flexbox spec. And then once that's done, it actually gets sent over to a third thread, which is actually the main thread, which all of the actual views are controlled from. And so this actually gives a significant win, because on most iOS apps, it's really easy to fall into the trap of doing all of your work on the main thread. But what that means is that if you have some computation that runs a little bit longer, then your app will lock up and be unresponsive for that time. Whereas, which is why you've seen these frameworks, like actually Facebook released a framework a couple of years ago called Async Display Kit, which tries to make it easier to move your work onto a separate thread and keep the main thread really smooth. But in some sense, you get a lot of this for free using React Native, and we're going to try to keep figuring out ways to let you make your apps smoother.
There are certain ways in which a native interface is fundamentally different from a web interface, like touch events or other native based things. Are there any frictions here in dealing with those differences?
Yeah, I mean that's a great question. I mean, we have right now the event system that React Native exposes is pretty similar to the events that you would get on the web, and that actually works great for a lot of cases. But then there are a few cases where that breaks down. I mean, iOS has this really great gesture recognition system, and what that means is you can add what they call a gesture recognizer to a view, and so like they have one for a single tap on a view, and so you can add the tap gesture recognizer to a view, and if you want, you might also add a double tap gesture recognizer to the same view. And what's really great about the iOS system is that those gesture recognizers will actually coordinate and talk to each other, and so that means that if you press your finger down and lift up, which would ordinarily be a tap, it'll actually wait a half second or so to make sure that you're not actually going to double tap before firing off that tap gesture recognizer and calling the action for that. Whereas if you don't have the double tap gesture recognizer added, then it'll fire it immediately because it knows it doesn't need to wait for anything. And right now, we don't have a system like this built into to React Native, and so if you want that sort of logic, you'd actually need to build it yourself. But this is absolutely a huge area where native apps do work better than web apps is in the gesture support, and so we're thinking about this a lot and want to build out a really solid gesture system that integrates with the React component model and makes it really easy to build these things. And then what we can do is actually, once we've built that, our hope is that we can bring that back over to the web and let you build web apps that have similar gestures to native apps. And we actually think that this will make web apps feel a lot better and feel much closer to native apps.
If you were going to build a React operating system that was not based on iOS nor Android, iOS and Android are getting pretty old. I think there's a hunger for like a third player in this market. I'm sure you must be learning about all these things, just this cruft that iOS or Android has developed. What would you do differently? How would you build a React operating system?
That's a good question. So a lot of what an operating system does is not related to views or anything like that, and it's just the underpinnings of iOS and Android are both based on Unix or Linux, and I don't think there's a huge reason that we would deviate from that. But you're right that there are some areas where both on iOS and Android, especially if you're using it with a system like React Native, there is wasted work going on in the system that we're not taking advantage of, where we have our own event handling, say, but then the native code is also doing its own event handling, and maybe that doesn't need to happen at all, or it's doing this bookkeeping that doesn't really need to happen. And what's actually interesting is that if you step back several layers and just look at OpenGL, then that doesn't actually have this model of create this rectangle and keep a reference to it and then destroy it later. And what you have there is actually much more similar to the React model, where what we call immediate mode rendering, where just on whenever you render, you say exactly what you want to be displayed. And so what you sort of have is you have this GL rendering, which is immediate mode, and then on top of that you have this view system, which adds this imperative layer and these object-oriented instances, and then on top of that, right now we have React Native, which talks to that imperative layer. But it's possible that by getting rid of that layer, we don't actually boost that much. We won't actually have to do that much work extra that we wouldn't need to do. But we'll be able to avoid the need for that layer entirely, which might be a significant win especially for performance.
It's really interesting. You worked on the React developer tools. What are the React developer tools?
Yeah, so in basically all browsers today, you can right-click any part of the page and say inspect element, and that opens the elements inspector, where you see all the tags. You see the body and the divs and the spans and the inputs and all those things, and you can see exactly which attributes they have, and what styles are being applied, and which works great for a lot of web development. It's absolutely invaluable. It makes it way easier to develop apps than it was before those were created. But what we actually wanted was to extend that basically so that it, in addition to the low-level primitives, you can actually see your components and the component tree. So you can see, here I have my newsfeed component, and then inside newsfeed there's the newsfeed story component, and you can see exactly which props were passed into that component, and then the children that it rendered. And so our hope is that with these developer tools, it makes it a lot easier to debug your code when something's going wrong, because you can just look at the components and see exactly which parameters are going in and what's coming out, and so you can look at that and figure out which component is misbehaving, and then just jump right to the source of that component to fix it.
I'd really like to know more about the experience of writing a browser extension. What do you need to know? What languages and concepts do you need to know to build this browser extension that is capable of inspecting the elements on a web page?
Mm-hmm. So actually, so I didn't write most of the dev tools. We actually had this great intern this summer, Jared Forsyth, who basically spent his summer rewriting the dev tools. He made them much better than the old version. He did a great job. But the way it works is actually we developed it almost entirely standalone, so it doesn't rely on any of the Chrome extension APIs or the Firefox extension APIs. And what we do is, we actually have it set up so that it can just run in an iframe, and so it's entirely web-based. Actually, it's all written in JavaScript, and what it does is we actually run what we call the inspector agent in the web page that's being inspected. And what that does is it hooks into React so that it can get notified whenever React creates a new component or destroys a component or updates one, and then it actually just sends that information over to the inspector frame, which then keeps track of what the component tree looks like, and then the component tree that you see rendered in the extension is actually just a React component. It's all written in React, and we just render that tree with all of the component data that we've gotten from the page.
And the developer tools are currently supported by Firefox and Chrome, but there's a standalone app coming soon. What do you mean? Well, what is meant by the standalone app? Is this like an IDE?
It's not exactly an IDE. It's just really a way to run the dev tool sort of without a browser instance. And this actually is not really useful if you're developing React for the web, because you have your browser open already and you're using your browser. But for React Native, especially if you're running the app on your phone or in the simulator on your computer, then we don't want to force you to open a browser in order to inspect that. And so we think by making a standalone app, it's possible we'll have a little more flexibility there. But it's not a full-blown IDE, although Facebook does have an IDE that we've been developing. It's called Nuclide, and that it's designed to work well with React Native, and we don't yet have support for the React dev tools inside of Nuclide, but I think it's definitely something that you'll see sometime soon.
Okay, fascinating. So as I've been doing research for this week, I've come across some debates around web development, which I guess is not hard to do. There's always debates around web development. But there's an ongoing debate about Google's push towards web components. I guess there's some other people pushing towards web components too, but it's kind of this thing that's led by Google. Could you define web components and tell me what you think of them?
Yeah, so web components are a new proposed standard, or maybe it was actually standardized. It might be a standard now, but what it does is it lets you define basically new HTML tags that behave exactly how you want them to behave. And so one great example of this is actually the video tag in most browsers. It obviously shows a video, but then also when you hover over it, it shows the different controls. You have a play button and a scrubber, and oftentimes a volume control. And in most browsers, those are actually implemented in HTML and JavaScript. But when you're using a video tag, you don't actually have access to the internals of the video tag, and so you can't style that play button with your own CSS because it's encapsulated inside this video tag. And so what Web Components allows you to do is it allows you to build your own tags very much like the video tag, where you can build a date picker or a color picker, or basically whatever you want, and then it will just be exposed as another tag that you can just use. It goes into the DOM. It looks just like any other tag. You can use jQuery with you can even render it using React, just like any other HTML tag. But the thing that is not so great about Web Components is that the programming model for actually building them is not that great. It's it's very similar to how you would build code without React. It's very, very imperative. You need to do a lot of bookkeeping yourself, and it's very difficult to actually build up large hierarchies of these components and pass around structured data without serializing to strings in the middle, because actually the boundary between web components, you can only pass strings through, whereas most of the data structures in your application are probably not plain strings, and so it makes it a pain to pass data through these different levels of components.
Are web components mutually exclusive with React?
No, they're not. And so, like I mentioned, you can use a web component inside of a React component, and we also want to make it possible to use React to build web components. And I don't recall if we're exactly there yet, but we don't actually see a huge advantage in doing this, because you can wrap each React component in a web component, but then that just basically produces extra overhead if you're going to be using them all together using React anyway, because you need to convert things to strings and backwards, and you sort of have this global namespace which is a little bit annoying to deal with if you're used to having JavaScript module systems where everything is nicely scoped.
Sure.
And so web components can be useful as the boundary, but between different frameworks. I think, like, if you want to make a great date picker control and open source it so that anybody can use it, I mean, that's what web components were really designed for, I think, and they do work well for that purpose, or they can, but web components don't actually really help you structure large applications and build up these large component hierarchies and compose these independent components together in a way that it is really easy to do and easy to reason about. And so we're actually not using web components at all here at Facebook.
Interesting. So Facebook, as I understand it, migrated the entirety of Newsfeed to React. Is that correct?
That's not quite correct. What we do have is the when you're looking at your homepage, then under each story, you have these buttons like, comment, and share, and then you have a list of comments underneath that, and so that is actually all built in React, the likes, comments, and shares interface. But and that was actually one of the very first projects to use React at Facebook back when but before it was open source and before it was really as stable as it is now. But it's not true.
Well, but now that it is stable, is there any sort of edict to update across the company to getting just React everywhere? Like this is, I've heard, you hear the term brownfield application development, where you have an application that's already written and you want to update parts of it to have something very specifically different. So is there anything? Is there any edict like that for React?
No, I mean, that's just not how we operate as a company. We don't say, oh, you need to rewrite everything on the Facebook site in React now, and that's like the thing to use. Basically, the individual product teams use whatever is most valuable to them, and so what you'll see is actually that certain things on the Facebook site lend themselves really well to React because they're super interactive. I mean, even just the likes and comments interface, you might not think that that's super interactive, but you have to type into the when you're writing a comment, you type into this text box. If you can mention somebody else, and that'll link to their profile. You can type smiley faces, and those turn into smiley faces, and then it also does live updating with data it gets from the server, and so it's a little more complex than it might appear. But then we're also using React for things that are very obviously interactive, like the chat windows on the site are all built in React, and the notifications panel, and so some things like that. And those teams have chosen to use React because it helps them build their product better. And so actually, when you look at the Facebook homepage, that's actually one of the places where you see React the least, just because we try to, we're very sensitive to any changes in the homepage, and if something is a few percent slower, then that'll actually just mean that fewer people use Facebook, and that sort of thing. And so we're super sensitive to those sorts of changes, and we try to test them very extensively to make sure that the new version is as good as the old version. And I think we'll probably see that we'll continue to use React more and more over time. We have a couple experiments where we're rewriting what we call the composer at the top of feed, where you can just write a new status update. We're looking at redoing that in React, and have run a few tests with that. And just more and more over time, you see small pieces convert over to React, but it's never because we never mandate the use of React, and it's just the individual product teams converting things over because they think that it'll help them build their product better.
Awesome. So I'd like to begin to close off. What are we going to see in the near future and in the far future for React, and what would you like to see?
Yeah, I mean, we're just really trying to figure out how we can stabilize React, I think, and make it a better developer experience. I mean, we just shipped last week a new release candidate for React, which actually has about 6 months of work in it. And one of the big focuses for that release was just improving the warning messages that we give to developers when they're doing something that might cause problems later on. as one example, it used to be that if you nest HTML tags in an invalid way, like if you actually nest two paragraph tags, that's actually invalid HTML, and the browser, when it sees that, will move around those tags so that they're siblings instead of a parent and child. And what that does is that actually confuses React, because React looks and it's like, well, I expected to see this paragraph inside the other paragraph, and it's not there, and it gives it this weird error message. And so I ended up adding a new warning so that when you try to do that, you get a very clear error from React that says, oh, you can't actually have a p tag as an ancestor of another p tag, and it was in this component that you rendered it, and you should probably not do that. We added a few more warnings like that really just try to help you and prevent you from having errors that can cause you problems later on. And so we're always trying to make improvements like that. Another big focus for us in the coming months is just improving performance. I mean, it's already fast enough for a lot of things. I mean, many things on the Facebook website use React, and on other companies' websites now as well. We have a couple apps in the App Store now that are mostly or completely built in React Native, but at the same time, we look and recognize that there are things that we can do to make React faster, and so we're trying to figure out how we can do that, and really just improve the entire experience of building with React. Maybe we can do other things like bringing a gesture system to the web, like I mentioned already. That'll make it easier to build really smooth, fluid apps. And then there's other things like just trying to make it easier again to manage your data in React, and make it possible maybe to save the state of all the components in your React tree, and then when you later come back to the site, maybe we can just deserialize that state and put the page in the exact state that it was when you left it, so that you as an application developer wouldn't need to worry about writing a lot of code if that's what you want to do.
Fascinating. Ben Alpert, thanks for coming on to Software Engineering Daily. It's been really great talking to you. You've had some super fascinating things about React to say.
Thank you. It's great to be here.